Okay, let me introduce myself first. I'm a psychologist studying human group behavior at the University of Tokyo, and my recent research revolves around two themes. First one is emergence of social norms in groups and its neurocognitive ecological underpinnings. And the second one is collective intelligence beyond the wisdom of crowds in group decisions. We recently wrote a review article on the latter topic. So in this talk, I'd like to illustrate some of the arguments in the review paper while focusing on cognitive and behavioral mechanisms that can yield collective intelligence in group decisions. There are two types of group decision-making: consensus decision-making, in which members are required to reach a consensus, and combined decision-making, in which members make individual decisions while being influenced by other members. And a major difference between these two types is that in combined decision-making, members do not necessarily aim to coordinate their actions at a collective level, and could also be driven fully by selfish interests, which may be expressed as tragedy of the commons. So these two things may lead to suboptimal behavior states due to herding, as illustrated in this famous cartoon. This is a summary table about information pooling mechanisms with human and animal examples. In consensus decision-making and combined decision-making, the y-axis here expresses distribution of information inputs among members. Aggregation mechanisms such as unanimity, majority, plurality, and so on requires equal information input among members, while accuracy-weighted group aggregation or despotism means skewed inputs from just a subset of group members. And as in Francis Galton's famous example, the wisdom of crowds requires equal weighting of individual inputs. So the wisdom of crowds is a statistical phenomenon whereby individual random noises are filtered out by simple aggregation mechanisms such as averaging. And similar logic also applies to the majority or plurality aggregation and quorum sensing. And these processes are widely observed among non-human animals as well, including such as swarms of honeybees, shoals of sticklebacks, troops of Tonkian macaques, and so on, which suggests that the majority or plurality aggregation are generally adaptive under conditions of uncertainty, solving the speed accuracy trade-off in group decisions effectively. Then, can we think of statistical aggregation beyond the wisdom of crowds? Yes, various aggregation methods have been proposed that capitalize on individual heterogeneity in knowledge and ability. However, assessing individual expertise accurately often requires longitudinal observation, as seen here. Also, optimal weighting schemes adjusted too closely to the available infinite data, that is, tuned too sensitively to noisy or unrepresentative elements of the training data, do not necessarily outperform equal weighting schemes when applied to new data sets. So this is known as a bias variance trade-off. So statistical aggregation weighted by expertise is useful, but its applicability may not always be so general in group decision-making. Then, rather than assessing each individual's expertise from outside through longitudinal observation, people themselves may be able to assess mutual expertise through direct social interaction. In such cases, subjective confidence seems to play a major role. And subjective confidence may be seen as a metacognition about own knowledge and accuracy. which can be communicated to others by verbal or physical behavioral cues, such as tone of voice, posture, like this. So expressed confidence may serve as a useful proxy for expertise. And this idea has been tested by Barami and others, and his colleagues. And their experimental results showed that peer discussion can indeed be approximated by a confidence-weighted aggregation model, which itself is very optimal, but it does not necessarily achieve the best possible group accuracy, like 2 heads are better than 1. Then can we overcome such limit of expressed confidence in group decision making? Yes, I think so. And here is our main claim. Opt-in or opt-out processes may be the key. That is, consensus decision making, including the Barami case, generally assumes that all members are required to contribute their individual judgment to the discussion. However, a viable alternative scenario may be that members are free to opt in or opt out of the consensus decision-making process. So, more confident members who possibly have accurate metacognition about their high expertise or accuracy are more likely to contribute, whereas less confident members who are possibly less accurate may refrain from contributing their judgment to the group discussion. And several experiments have examined the potential for improving crowd judgments by allowing individuals to select which of a set of general knowledge queries to respond to. As you see here, volunteered opt-in individual judgments were more accurate than forced randomly assigned individual judgments. Also, good responders tended to answer more questions than but responded. Good respondents also tended to answer more questions than but respondents. So, allowing responders to opt in has the potential to create a more informed knowledge base for group consensus. Of course, the success of opt-in or opt-out mechanisms hinges on the extent to which one subjective confidence serves as a reliable metacognition about high expertise. This is very true, but the linkage between expertise and participation itself may evolve through social interaction. Studies by Kameda and colleagues have demonstrated this possible linkage. In a forecasting tournament, members on the so-called super forecaster team provided information selectively only to questions which they are firmly confident about, and the other members who do not voice their judgments but possess high cognitive abilities judge the qualities of the evidence. So this means that the high-level cognitive division of labor emerged through social interaction, dictating who should contribute and who should just listen to and evaluate information, and when. But you may think that this is a champion data and applies only to a special teams composed of highly motivated experts. So let me turn to another strategy called copy when uncertain strategy. This is one of the most established social learning strategies across humans and non-human animals in combined decision-making. Here, I argue that this strategy is functionally equivalent to the opt-in, opt-out mechanism in consensus decision-making. So the copy when uncertain strategy is a social learning strategy dictating when individuals copy others. So individuals who have no certain information about a new environment copy others, while those who have information about applicable to the new environment behave based on their own knowledge. So copied behaviors tend to originate from well-informed asocial learners, while less informed social learners tend not to initiate behavior until they learn about it through observation. And it is important to note that such conditionality in the use of social information could be driven fully by selfish interest, so like the tragedy of commons. However, this dynamic can ratchet up the quality of information put within a group. So this works similarly to the confidence-guided opt-in, opt-out dynamics. There is some evidence for this claim. Several years ago, we conducted a series of information cascade experiments in Japan and in France. And in the experiment, 30 participants answered knowledge quizzes in a sequence like, what is the radius of the sun? And for a given question, each individual gives her first her personal estimate. Then, after receiving social information, like arithmetic or geometric mean of 3 preceding estimates, she gives her new estimate, which was entered to the social information as moving average. So you note that this could lead to erroneous information cascade via autocorrelated errors in the chain. So this experimental setup provides a rather challenging situation for collective intelligence to emerge. However, the results showed that social information did improve collective performance. This graph shows average performance in the first solo estimates shown in blue, and the second estimates after receiving social information shown in red. And the y-axis here means that the smaller the number, the more accurate estimates. So despite possible autocorrelated errors in the chain, collective intelligence emerged via social information. Notably, this pattern was observed both in Japan and in France, two countries that may be contrasted culturally in terms of conformism versus independence. Okay, what are the mechanics for this? So this graph shows the relation between individual confidence, subjective confidence, and accuracy. As you see here, the more confident this side, individuals tended to be more accurate. Next, this graph shows the relation between confidence and independence. As you see here, more confident members, individuals, tended to be less susceptible to social information. And lastly, this graph shows the relation between the degree of deviation of one's own estimate from the preceding social information, moving average. Less deviant individuals like this tended to be less susceptible to the social information. So these three behavior elements, which constitute the copy when uncertain strategy as a whole, as a package, contributed to the collective intelligence in the chain. Okay, let me wrap up. In this talk, I have argued that opt-in or opt-out mechanism, process dynamics may be a key mechanism for collective intelligence beyond the wisdom crowds. I show that metacognitive or higher order division of labor that capitalize on individual heterogeneity of knowledge and accuracy in various task domains can evolve in human teams, such as the super forecasters. And I should also mention that prototypes of such division may also be at least behaviorally manifested by some group living animals, such as leadership in group movement or collective risk monitoring between cooperative leaders and group foraging. And also, the copy when uncertain strategy is widely observed in both humans and non-human animals. So such metacognitive division of labor, such higher order cognitive division of labor may develop as an emergent property in groups of micro-size to meso-size with repeated interaction between relatively fixed members. And this process may further be facilitated by introducing some human-machine ensembles. But this is not within my area of expertise, so I should opt out here. Thank you very much.